Hello, welcome to the video. Today we're going to talk about the value stream mapping. Value stream mapping is the tool that's used to analyze and document the entire process of a product or services to the customer. Today we're going to write the value stream mapping of this simulated process in Flexsim. Here is consider at the receiving area. That's where we receive the raw materials. We have a high-low driver, pick up the raw material and put it in the rack, and that's considered like a storage. And there's another high-low, pick up the raw material and push it through the production line. So we have a different process here. We have like this is like a machine. We call it process A. Could be anything. So since it's just a model, I'm going to use just a different name, just like process A, process B1, process B2. And then we have a process C, which consider packing or loading the parts uh, in the pallet. The parts change its color. This is the item, which is considered the product that we are building. So we have one operator running the process A. We have two process since the cycle time is not matching. So we have like 10 seconds here. I have 20 seconds. So I need two machines to maintain a continuous flow. And then we have two operators, each operator running one machine here. And that's after the part finish. From here, we have a small web area, 10 parts. And then goes to the process B1, process B2. And we have a conveyor that push parts through the packing or the process C. We have a pallet that loads 50 parts. Then we have an operator running that packaging machine. And the last thing is when the packing finished 50 parts in the pallet, we have a high-low driver that's going to pick up the pallet and pack it in the finished good storage area. And then we didn't simulate what's going to happen next. I don't think we need to do that. We can just say that we have 20,000 parts as a customer demand per day, and we are shipping that like daily. So we have a truck daily to ship parts to customer. And like we can say that in the receiving area from the supplier, we receive once a week around 10,000 parts of worth of raw material. So the parts comes in within like a gray color, and they leave as a blue color. This is the value stream mapping of that process. Okay, we always start from the customer side. This is the customer. I call customer X. The product is one. That's the name, just the name of the product. And let's say the customer demand was 2,000 parts per day. So we put all the information here. Also, we put the daily, the shipping we have. We have one truck per day, and we ship 2,000 parts to customer. In the middle, we have the information flow. This shows how do we communicate with the customer. This arrows represent the communication flow. On the left side, we have the supplier communication flow, and then the supplier ship 10,000 worth of material, worth of parts to the plant, and also use a truck. So just show a truck like a picture or number of the trucks that we receive. So once we are done from the top, we start from the top to the bottom. The next step is we go through the inventory that we have between each process, and also how many processes we have, the cycle time of each process, the OEE of each process, and then we calculate or collect the data like how many inventory we have between each process. So this arrow with this color, this represent the material flow. We have a high-low driver, pick up from a truck, put it in the storage area. We have like a 10,000 parts, and this is representing this storage area. So this is the high-low, he put it here. Then we have another high-low driver, pick up the parts from the from the inventory and bring it to the line. This is a second high-low. Take parts, load it to the process A. The cycle time is 10 seconds. C dash O, that's a changeover. We don't have any changeover time. We are just building one part. The OEE is 95%. That's a number that's a data that we collect. Operator is 1 when we have one operator and we run it in one shift. Normally we should have the available time. I already have the available time here. It's 8 hours per shift, and then we have one shift of operation each day. This is how much time available. Okay, so once we are done here, go to the next process. Before we do that, we know that there's 10 parts of inventory we have here. So this is the 10 parts of inventory. And then from this inventory goes push parts to the next process, which is B1 and B2. We know the cycle time of each machine is 20 seconds. Let's go back here. We have 20 seconds cycle time. We use one operator for each process or each machine. And when it's done, the part's going to go through the packing, which is process C. And the inventory is 2 parts. And then goes to the packaging. The OE we have one operator. And then, as you can see here, we have one process, packaging, one operator. Finish the packing 50 parts. And when it's done, the high-low driver going to pick up the finished goods and load it to the web. So here we have the inventory of the shipping goods, 2,400 parts, and that's represented here in this storage area. So once we finish this, the inventory, the processes we have, the last step is collect the information of the lead time and the value added time. So here is always on the top is the lead time. The way we calculate the lead time is we collect, like, okay, I have 10,000 parts. That's the inventory. And we divide that by the daily customer demand. So all we have here, we have to make sure we put that, if this is like customer demand in days, so we have to convert days to seconds. And that's we have like, okay, 10,000 parts divided by 2,000. And then convert to seconds is going to be 18,000 seconds. And by adding all these lead times, we have the overall lead time. The next step is collecting the value added time. The value added time is normally the cycle time of each process. So process A, we have like 10 seconds. Process B1 or B2, since it's one part each, becomes 20 seconds. And then process C, it's 10 seconds. So that's the 40 seconds value added time. And then the last thing is we divide the ratio. This is the 0.22%. That's the ratio between value added time divided by the lead time. And the goal is we always actually reduce the lead time by reducing the inventory. That way we have actually bigger ratio. Bigger ratio is more optimized process. This is very basic value stream mapping. We can use that to learn how to start or make a value stream mapping for any process. This is all I have for today. Thank you for watching, and I talk to you later.